This whole talk is based on the use case study I wrote about our system for CosmosDB team, and this basically was published on Azure blog. It has 3 parts, so you can read about it. So once again, so I'm coming from Prague, from Microsoft. I have a blog. You can find me also on Twitter and on LinkedIn. First, let's do some introduction to our system, so you know what we will be talking about. The service which we built is basically for feeding, the contacts. If you use Skype, which is probably not so popular here, as I saw, unfortunately, but if you use the Skype, there is tab, for contacts, and this is basically the place where you see all of your contacts, all of your groups. The contacts have names and so on, and this is basically the part in the Skype which we are filling, with the data. Not only this, but also this. Just few facts about our system which we are running. We are serving more than 2 billion of users or address books in a size 150 of terabyte of data. We are running the system, which I will be talking about, for more than 2 years, and we are basically globally deployed to 7 DCs now. In the peak time, we are serving 5,000 writes, 15,000 reads per second. These are like the peak times and so on. We are aiming to hit QoS 3.9s, and we have also some strict rules for SLA, what we need to meet. And this is basically the thing, this last thing what I was mentioning is basically the main reason why we started to look into such system, because when we were running the previous system, we had really big issues with QoS and with times and so on. So let's look how the previous system was working. I was also the main guy, or one of the main guys who were designing, who was working on the system from beginning to the end. So this was also my failure. It was built on request architecture. What does it mean? It means that we have a client which is sending us some requests. On our side, on service side, we are just reading some state from storage, creating or doing some domain logic, calculating the state, then saving the state, and then usually we need to synchronize or to sync with other systems, like for example the graph search, like notification system, and so on. So this is basically what we were doing, right? And at the end of the day, we return then the whole response back. The pros of this code was that it was very simple to write. It was really done very quickly. We were quite happy that because we met the deadlines. But the problem was, as I was mentioning on previous slide, that we had the problem with QoS and with SLA, and also with some other things. I will talk about it. So first thing was that we were dependent on other systems quite massively. So when some other system had some issue, the request took quite a long time, we were also, impacted. And you can imagine that calling, the incident in the middle of the night because some other system had some issue was not very nice. The same issue was with some other system was had some outage. The same thing. So we were quite disturbed very much. The problem wasn't in our code per se. The problem in that case was with outage of some other system. But we had the code written in such a way that we were basically impacted. And the last but not least thing, we had many reports from the users which were just complaining, hey, I see the contacts, or I got some message, or I got some notification that I should know this guy, and this guy I don't know where they are coming from. I have some broken contacts and so on. And these escalations came directly to us as development team. So you can then imagine what we did. So me personally, we were contacting the users and trying to get some information. Hey, what's wrong? So you can imagine how big now is my address book, right? like 5,000 contacts, and most of them are some strangers from the world where we talk about the issues in Skype. So it came to such a situation that we got strict the business requirements. At least 3 nines. That's it. And which means if you are dependent on 2 systems only, you are forced, or you are going to expect that these 2 systems has at least 3.5 nines. Together with the issues with times, so latencies were also one of the core requirements, because when you are setting up the call on Skype, we have there some limited time to check if you are able to call him, if he didn't block you, and so on. So this was also quite interesting to meet, and because of these reports from users, we wanted to know what's going on in the address book. So we put some extra requirements or ourselves that, hey, let's have there some audit log. So we had to address these issues, and now I will drive you through some proposals what we did to address all of them. So first we had the problem with latencies with QoS, and because you saw on previous slide, and I will be just going now. We decided we will be splitting this domain logic part from the integration part. So basically, we will splitting the system into the 2 parts. So by this, we were able to fix, to mitigate to some degree, QoS issues and latencies, because in that case, the system is depending only on our code and only on one system like storage, which we will be using for storing the data. Then of course, you are also dependent on network, on DNS, and so on, and they have also some outages, right? In cloud, in Azure, we had a big outage last month on DNS. So then you need to take this into account. So we split these 2 parts. But we had a new challenge, how to coordinate these 2 parts. So we were fixing QoS issues and latencies. We have a new challenge, and the challenge with keeping system in sync still stays. On the previous slide, here is one more issue. Just imagine that you just did your business logic, you stored the state to the storage, you then are communicating with some system number 1, like for example, with graph search we did, and then you are going to talk to second system, like notifications or something else, and the system is out. So now what do? You already changed your state, you already just informed some other system that, hey, this is now current state, but you are not able to reach the second system. Now what you will do? Whether you will have there some logic to compensate this, or I don't know. So then our code started to be quite complex to solve all of these issues, and this was not going to good direction. So we did it, to address this, and I will be talking about it, just later. And last requirement, what I was mentioning, that we needed to also track, some audit log. We need to get some audit log, what's going on with some domain, and we were inspired by event sourcing. So events are basically. So, this event sourcing says you that all of the changes to your domain are represented as some stream of the events. And if you want to get the current some state, okay, what is my current state? I need to replay these events. So the event starts to be source of the truth. So let's look how it is working. So let's say that I have 3 events in my storage for my domain, and now this is the state. And now once I get the state, I will do the business logic. I'll create new event. then a new state is like A, B, C, and D. Fine, but this has a problem. The problem is that this is time-consuming, resource-consuming. Basically, these events can be going from 0 to sky, and to replay all of them all the time is not very good. So the solution to this is to create some snapshots. Okay, so we will create some snapshot. So okay, we will record the snapshot at time 0. So then new state. So that when I want to get the current state in T1, it will be state at time T0 plus the new event. Fine, but should I keep the states once per week, once per day, once per month? What? So what basically we decided? We decided that we will be having the snapshots all the time up to date. And we basically were inspired by second pattern, which I would like to talk about. That's capture state pattern for Martin Kleppmann. He's saying that, or the thing is that all of the changes to the storage creates also the events, which have not only the event, which have not only the change, what happened, but also current snapshot. And we also added there one more thing, which is metadata, which we will be recording and which we'll be using for some other purposes. I will be showing it to you. So we used this pattern, and we were doing it. He's mentioning that he's doing it on DB level. We were doing it in the code. So let's look how it would work from the high-level perspective. So we get some requests from a client. We do the business logic. We calculate the new state, and then we will be storing everything inside one transaction to the storage. This is from one part. So we will be storing there not only the current snapshot, like current hour data, like some items and the root. The data about domain root aggregate, but also the events. And everything these will be stored into the storage under one transaction. And this is on the first side. This is on the front end side. Then from the back end, from the background side, we will need to get from storage stream of the events, which will be usable for us to feed, to power, the background part. And this is basically the requirement. This was basically the requirement which we put on storage. We needed to find some storage which will fit our needs. And we opted in for Azure CosmosDB. Just a short intro. This is basically a schema-free database where one table is basically one collection. In the collection, you can store any JSON document. It supports SQL syntax to some degree, the indexes and so on. Cool feature if you are working on enterprise application is that it is also geo-replicated. And it's scaling quite nicely with a focus on storage, like size, as well as on throughput. But for us also was very important that they have very nice with SLA, like they are able to serve reads and writes within 10 milliseconds, and they have 5 nines. And in order to meet these strict limits, the way how to go is with to go with multi-partition collection. So basically, your big database is split it into the several partitions. And they have two really good features, like transactions, which are per collection, per partition, and the change feed support. Change feed support is that streaming of the events. And I will be focusing on this very much because this is heart of our system. So let's look just briefly how it is looking. We split the collection per user. So basically, the partition ID is user ID. and we store document per basically each item. So we have documents of type like the contacts, groups, user, events, and so on. And when we do some change, we store it inside one transaction. So so inside one transaction we store not only these items but also these events. And now we will be going through each of these parts of the system, so we will see how it's working. So let's look at the first part, which is CosmosDB transactions. So just a short intro. If you want to play with CosmosDB just on your local machine, you can download it from web. It will then be running on your box. Locally you will get there also the web browser. In the web browser you will be able to get also some details about the connection string. There is also some IDE where you can play with all of these things. And because this is a database where you are storing JSON documents, storage procedures are written in JavaScript. So this is only the way how you can force the transactions to be done. So the transactions are done only via storage procedures, and they are written in JavaScript. I prepared the demo. On my GitHub you will find all of the demos. So in this demo I'm going to create the local database. I'm going to add there the storage procedure, because this is the only way how you can do the transactions. And at the end of the day I'm going to store these documents. Just briefly, this is for example the storage procedure. Here you see we are getting some data. We are then just iterating over this data and calling or basically just registering the commands to the sandbox. So basically the storage procedure engine is working on some sandbox, and in this procedure, I'm basically just adding there these commands, and at the end of the day, when the function will finish, the whole sandbox will be committed. And here is how I will be adding in this demo the storage procedure to the DB, and this is how I will be storing it. So here on this sample, you can see that I will be storing there, I will be calling there, three methods. First two are for adding, the documents one by one, and the third one is over this procedure. Pay attention, there is, session token, and in this token it has the format as partition ID, transaction ID. We will be using this transaction ID later, and I'm, just adding it, and then this is over the procedure. So this was on the first part, how we basically are storing the data to the storage. Then now let's go and talk about the second part as a feed. So first, what does it mean? The feed is, gives us the possibility to receive all of the changes what happened to the storage. So all of the changes what you did to the storage, like you added some document or deleted, blah blah, they are received on the second side as a stream of the events. And if some document was changed several times, you will get only the latest snapshot. What does it mean? In this demo or this slide, I will just add there one document A, which is at version 0, then document B at version 0, and then I will change A to 1. When I will be reading the documents, I will get only these two. And in this order, this ordering is very crucial. So then again, I have some demo. It is based on previous, so here I'm just focusing on starting the processor. When you are working with CosmosDB, there is the SDK from CosmosDB. They open the whole API for reading the feed. But if you are working in scalable manner, when you have several partitions, several nodes which are handling this partition and so on, it is quite complex. So I was one of the guys who wrote this project, for reading the feed. It is on GitHub, and it is also under CosmosDB now. So in this demo, I'll be showing you the Cheche processor with the builder pattern, where we will be setting up. You will set it up that, hey, this is the feed of this is the source where I will be getting the events from, and all of the events will be deployed or basically just dispatched on the console observer, which is here. And in this this short demo, I will be just printing them to the console. So let's look how it will work. Here I have a feed of, here I have some documents which I just edit, and you can see that I have there one document. So one document with this transaction ID, second document with this ID, third document with this ID. But document A is changed here and here. So when I will be reading the feed, I will get B, C, and then this A. And let's see. So what I said, document 2 for user B is with this transaction ID, which is here, then this is here, and this document for user A in the version 2 is with this ID. So now let's bring all these things together. What we are doing, this keeping latest snapshot was quite freaky. So this is the reason why we had it to adjust our system. So what we are doing, when there is a change, we record that we do the change. Like for example, in this case, we insert the document A to version 0, and then we also record that change, and we store it under one transaction. Then we do the same. So if we do the change on document A, so now it is in version 1, we also record this event about this change. So when we will be reading these events, we will get this, which means the events will need to be in the append only mode. So we will not lose the track of any change. So if you do block unblock block unblock, we will get all of these events. Here is some demo about it. So here I have also some changes, what I did, and as you can see here, this document A has now this transaction, this here, and then these all 3 documents under one storage procedure have this transaction ID, and you can see them here. So now let's look into the details how the background processor is working. As I was mentioning, this is basically the heart of the system. And the events are basically some state which was in past. We have there 2 golden rules that the events has to be complete enough, so that the consumers, the background parts can work on its own. This was one thing. And change state pattern, or the capture state pattern, it helped us. And from the background part, we never ever go directly to DB for writing. We only getting the stream of the events. So let's look how the system will work. So on one side we have the events. On second side we have our business logic, like event handler, which we'll be calling as an external system. So, and we know that we will be reading these events through the change feed. Everything is fine, everything is good. What will happen if this system will be out? We have 2 choices. Whether we will try, and retry is here, but basically the whole system is paused. Or, and this is what we did, we added there, some retry logic, some retry queue. So basically, the events which we were not able to process, we put them into the queue so that they will be, retried some later in the time. And if we have some events or bug in the code which are not able to be processed, then we will store them in the letter collection. So we have there, this support. And because this is quite a common concern, we will now, so it is in one package. We will basically, be open sourcing this package so that other people also can use it. So let's look at some demo. In this demo, I am setting up a queue because this is used for retry queues. And then I'm setting up this processor over this library. And here you can see that I'm setting up the failed message will be retried 3 times. And then I'm setting up also that storage for that letter. And then all of the changes will be dispatched to console feed handler. This is how this is some demo. And here I'm showing the document sproc3 will be failing. So here is the output of this demo, and here you can see that this document was retried 3 times. So first time it was processed from the main feed, and then 3 times over the retry. But there is one really bad issue here. The issue is that we are now starting to process the events out of the order, because for same same contact we can get some event which is coming from here and then also from here. So we need to solve it somehow. The solution to this is versioning, or what we took was versioning. So what we did, we split our whole domain model and these things to property sets. So we have there, and each property set has some version, and we have also versioning on API on the input and also on the output. So we have their so-called versionable properties, and we had to have there also conflict resolution algorithm to resolve the conflicts. We were quite inspired by this paper, which is describing how to solve distributed transaction across the system in the cloud, for example. Because in the cloud you cannot have some such transactions, right? The systems, they are operating quite on their own. And the thing is that this helped us also to solve the last challenge, which I didn't talk about yet, but this was that we had the problem that we were out of the sync with other systems. So by this, we do the change to our storage, to our domain, and then we are just synchronizing this change to others, and we are propagating their the versions, so that our system is up to date, but like whole product is eventually consistent. So at the end of the day, the goal is to converge to the same state, to the same state or result. Yeah, so the coding was done, right? And we wanted to go to production. But before going to production, you need to do the tests, or basically you do the test while you are coding, right? So there are different levels of the tests. I would like to focus on functional testing here, just briefly, that we are able to host the whole system in the memory. On the input, we are just hosting it over the Kestrel. Then all of the outbound calls are also over the Kestrel with some mock-queue tiny layer. This project we will try also to outsource it, because this was quite nice, sugar, so that in our test we are doing them in AA style. So arrange phase will start it together with storage. And the scope of this test is to prove that our system is working correctly without taking some dependency to other systems, but except storage. So this is basically our suite for testing. So in arrange phase, we will start it in the memory with Kestrels here, plus we set up the mock. in act phase we'll trigger something, and then in last step, last phase we'll check that we have results correct and so on. There was one of the issue which we had to face is that we wanted to get also the visibility what's going on in the system. And one of the solution was using the correlation vectors. So correlation vector is a standard for tracing the events which are spanning your components or your products. So with this, you are able to track what's going on in that specific components. So for example, here, we can get from some service or some client some correlation vector. We will then just add our part, and then we will store it into the storage. And this is, for example, one of the things where, the metadata in the event was used for. So in this metadata, we are storing also this correlation vector. And then when the background processor is starting to process it, we'll just use this correlation vector, add there some subpart, and then we will just passing it to other services. By this, we are able to look at the system if we have some complaint. And then, hey, what's going on with going on with this ABC call? We can see what's going on with this call in our system and also cross product. We were leveraging, as we are working on ASP.NET Core, 3.0 will have the native version for it on inbound also as for outbound. We are using there this external login scope, the provider, which is working on top of the async local. Metering was also one part of which we had to address. So we are able to measure QoS and the latencies on the input, also like age of the events, how fast we are able to process the events, and also end-to-end like total. This is, for example, graph which is showing from production. On X line you have time, on Y line you have the milliseconds. This is basically for events, how long they are staying to be the process and so on. This is the team which built it. It is not just my thing, this whole team. And the summary. If you want to look at more details and so on, you can look at the paper. At the paper. This book from Artik Lepman is really awesome. We were inspired from it very much when we were building the system. And you can find me also on the blog. This is a link to the case study. Here I will publish the source code, what I used for demos today. This is a link to the processor which I was working on for CosmosDB. And this we will open source soon that ASIC processing library, which we use there. And we got some feedback that it would be good to open source it, and so that it is quite usable also for others. Thank you very much. That's all. I hope I meet time. Thank you very much.
Thank you very much. Oops, I stepped into something. So, does anyone have questions? One here. Who is next? Raise your hands in advance, please, so we can pass a mic to you.
Okay, thank you very much. Can you please go back to the slide where we had insert and update the storage?
You mean this?
Yeah, a little bit earlier.
This?
No, the diagram.
A diagram.
Yeah, right here. So here, insert and update actions. Are they on snapshots? Do you mean snapshots by this update?
Update here, it will basically be current state. Will be current snapshot. So this is the snapshot, what is there, and plus the event, what was done. So the change, is metadata, and also the snapshot.
Okay, got it. So how did you decide on the frequency of snapshots? We personally had a lot of
up to date.
Yeah, but how did you decide to do this up to date as opposed to other frequency?
Yeah. So we have the scenarios when the clients, when they do the write, they are coming back to us, and they want to read or they want to sync the state. So what then it would mean? It would mean that we would need anyway to calculate this state. So this was one thing, and the second thing was that with every write we would need to just calculate it once again. So basically we decided no, let's not. So once we spend a time on calculating it, let's not throw away the end result. Let's store it. This was basically the decision what we took.
Okay.
Okay, next questions at the end of the, yes, you. After that, one question's here, and after that, here.
Okay. Do you have situations when you release some event, and then during time, business says that we need to change some event, and how do you handle such situations?
What do you mean that we need to change some event?
Semantics, for example, create user at the first time it was just username, and then we want to add email in the create event. So how do you handle changes in event?
On API we have task-based API, and basically if such case will come, we will record new type of the event. So each event has also a name, so that we are able to filter it.
Well,
but the storage has already this new field, so this event will have this new field already.
And what about situations if it happens frequently, and then you have many versions of the same event, and it can cause a lot of legacy code that is not used anymore, but it is stored just because we need handlers.
Yeah, so with this situation, what we do, just imagine that we will add there this new field, right? These events, they have their, some lifetime. So basically, we don't keep all of the events all the time. Yeah, they have. We said there that we will, and due to the GDPR rules, we are able to store them by 28 days. So we will have this legacy code only for this time, because we want to clean up the code.
Okay, thank you.
I would like to get the question for this because I would like to answer or add one thing for CosmosDB what we did for ref, struct, and so on. We have there we had there a situation where this ref structing helped us very much. Or we can talk them later.
Yeah, thank you for your demonstration. The question about the background processing, in the event sourcing, order of events is important. Yeah, so then processing of such events is order of processing such events is important too. So I faced with a situation when such background processor is like a bottleneck, because we can sequential is important. We cannot parallel processing in different trays. Yeah. As a result, it affects final time when we have this eventual consistency. Did you face it with such situation? Do you have some ideas how to resolve?
Yes, so these events are scoped for only one domain. So basically, when we are process, so this situation can happen only if you are inside one domain. So if you have one domain and you have their block, unblock, and you need to do something about this. So yes, this was this is the bottleneck. This was the reason why we added there versioning, some retries and so on, and also so if I have there two concurrent events or block unblock. This is with version 1 and with 2, and I will be processing them like this or like this. So if I will first be processing 2 and then 1, then when I will be calling their back to the second domain, hey, do the change with 2 and do the change with 1. This one will be dropped because it is because it will be already on 2. So we had there to have some algorithm to resolve this conflict, and we had to split our domain to some distinct parts. So if I have only, some username, no, if I have, for example, some phone, the phone can be changed only by, the client. So this has its own version.
Okay, and this is me again. So, Frantisek, can you describe the broader landscape for your solution? As far as I understand, it's completely Azure-based. So can you describe where do you host the ASP.NET Core? What type of QoS are you using? Like what type of additional services, application insights, I don't know, alerting? And do you have any kind of analytics on top of?
Yeah. So we are working in Microsoft, and there are many the internal tools which are there, which are going out. For example, for monitoring, we are using the system which is now published on Azure as Azure Monitor. But this is only some light version. We have a much richer version on background, and we basically are recording there all of these things. We are recording there all of the metrics and also the logs, like structured logs and unstructured logs. This is inside inside our tool set. But unfortunately, this tool set, it is scoped for Microsoft. So I don't know if it makes sense to share it because
Okay.
So we are hosting it as PaaS V1. So we are still working on cloud roles. Yeah, cloud roles. That's compliance solution. We need to meet also the compliance rules. But we will be moving to .NET Core, blah blah. But now as of now, most of the services are running as PaaS V1 or as the Service Fabric. Yeah, but these are like only a few of them.
Okay, time for last questions. I believe there was one.
Yeah, so I wanted to ask, which guarantees do you have from CosmosDB regarding the fact that when you record a change in a transaction, right, does it guarantee that it will send out the change feed? And what is the guarantee? Like,
Yeah, because this
is it transactional or?
Transactional log, yeah. They are going over transactional log.
Okay, so if the change feed is not get sent, then the data is not persisted, right?
Yeah.
Okay, thank you.
And there are just side note. You can opt in. Let's talk then later about it.
Okay, thank you very much. Okay. And now we have coffee break.